Hello friends, welcome to ClassFly community. Today in this video, we are going to discuss about multiplexing and demultiplexing, endpoint identification, connection oriented multiplexing and demultiplexing, connectionless demultiplexing and multiplexing. Multiplexing and demultiplexing. Multiplexing is assembling is nothing but collection, and demultiplexing means distributing. So let's go in detail what is multiplexing. Host to host communication is in network layer, which is extended service to process is in transport layer. Let's see this diagram. Let me explain through this diagram. You can see here P3, P1, P2, P4 are the processes. Assume that there are three hosts, host A, host B, or C, like wise. In the first source, in this source, we have only one processor, that is P3 running. P3 is the one processor which is running in this host and assumes that the sender sends a data from application layer to the transport layer. When the sender sends the data from application layer to the transport layer, the data do not go directly, it needs a socket. The blue rectangular box represents socket. Socket is nothing but it is an application programming interface. Application programming interface means it acts as an intermediate between the application layer and the transport layer. That's it. And from the application layer, the data chunks through socket will transport to the transport layer. From the application layer, the data chunks are transported through a socket to a transport layer. In this transport layer, the data chunks will be encapsulated and forwarded to the network layer, below layer. The process of collecting the data chunks from the different application. After collecting it from the socket, just forwarding all the data chunks to the transport layer and the transport layer here to further layer. This process, what the process happens here is called multiplexing. The process can have one or more sockets. Here, for example, this process is having a one socket. It can either have another socket. The sockets are used to pass data from the network to the processor and vice versa. Multiplexing. What is multiplexing? At the center, the transport layer gathers the chunks of data from the application layer as I said, and gathers the host from the different sockets. Encapsulate the data chunks. It will encapsulate the data chunks with a header to create segments and pass those segments to the network layer. Then the transport layer will pass those segments to the network layer. The job of combining the data chunks from different sockets. What this socket does it? Job of combining the data chunks from different sockets to create segment. This is called multiplexing. And next is here the P1 processor. What is happening here? Let's see now. Here the socket, as we know, for the socket we'll have destination and source port number both. Now here the transport layer, which is here, will collect the data from the network layer will collect the data from the network layer and deliver it to the appropriate processor through the appropriate socket through its destination or source port number. This process of receiving the message is called demultiplexing. And here this P2 is doing multiplexing. Again at this P4, demultiplexing. At the receiver transport layer examines the field in the segment to identify the receiving socket and directs the segment to the receiving socket. The job of delivering the data in segment to the correct socket. What exactly happens in demultiplexing is it delivers the data in the segment to the correct socket processor is called demultiplexing. Next, endpoint identification. Now coming to the socket, you will have each socket must have unique identifiers. Each segment must include 2 header fields to identify the socket. Which are those 2 header fields means source port number field and destination port number field. Each port number is 16-bit number and the port number range from 0 to 1023 are called as well-known port numbers or restricted. And you can see this diagram. We have, as I said, 32 bits it contains, and source port number, destination port number, other header fields, application data or message. Connection oriented multiplexing and demultiplexing. Connection oriented multiplexing and demultiplexing. Connection oriented means TCP, as we all know. Let me go with the diagram first. The host A, here you can see the host A sends some data which are fragmented from transport layer. It's not mentioned here in the stack. You can see, as we all know, application layer, transport layer, network layer, and so on. Host A sends some data which are fragmented from transport layer to the network layer for further transmission. So there's some segment. There are some segment which has a source port number for the client. For this client is having a source port number and the destination port number for the server. At the time of sending, this client is having a source port number and the server is having a destination port number, and the source port number is 19157 and the destination port number of the server is 46428. At the time of sending back to the client, means the server is sending back some message to the client, it just get reversed. The destination, the new source port number will be the old destination number and the destination port is the old source port number. It just reverse. So this is how it is. At each TCP connection has exactly 2 endpoints. Thus, 2 arriving TCP segments with different source port number will be delivered to the 2 different sockets even if we have same destination port number. The TCP socket is identified by 4 tuples. 4 tuples, which are those names: source IP address, source port number, destination IP address, destination port number. The server host may support many simultaneous connection sockets. Each socket will be attached to a processor. See, you can see here, this socket is attached to this processor. Identified by 4 own tuples. Then it will identify all these 4 tuples. When the segment arrives at this field, it just identifies all 4 tuples. Then send it to the segment to the appropriate socket, and it's delivered to the client. And this is how connection oriented multiplexing and demultiplexing works. Coming to connection-less multiplexing and demultiplexing. Connection-less is our UDP. At connection-less, what happens is, at the client side application, the transport layer automatically assigns a port number. Here, at this client side, the transport layer assigns a port number, whereas the server side application will also assign a specific port number for this also. At the sender A, this host A transport layer, in this transport layer creates a segment containing, and it creates a segment, this is called a segment, containing source port 19157 and destination port 46428 for the server, and data pass when resulting segment to the network layer. It creates a segment containing source port number, destination port number, and the data passes then the resulting segment to the network layer. What happens at the B, like server B? This is a receiver side. At the receiver transport layer, what happens here? Let's see. Examines the destination port number. This will examines the destination port number field in the segment. This examines and delivers the segment to the socket identified by 2 tuples. It will identify its destination port number and IP address. It will check those 2 tuples and delivers the segment to the socket. This is how connection-less multiplexing and demultiplexing works. Hope all understood. Thank you.